thank you. Okay, today I want to move to the social chatbot, and you can compare the difference between the goal-oriented and the social chit-chat. So this is the outline of this talk. In the beginning, we will talk about the introduction and the background knowledge a little bit, and move to the social chatbot. And we want to focus on the evaluation more compared to the goal-oriented one, because for the social chit-chat, evaluation is an issue, and we also be asked this question yesterday. Also, we will also talk about the recent trend and some challenge in the very end. Okay, so let's briefly introduce the background. Now we know that we already have the 3 different types of task-oriented dialogue, and the first one correlate with the social chit-chat. So today we want to focus on this interaction. It's just like the Turing test. We want to have a natural language interaction together with the human. So based on this intelligent system, we have the goal-oriented one, and also engaging social bot. Like we want to have a good greeting and also maybe provide some interesting response, like a joke or some engagement behavior. Although we separate it into 2 branches, like one is about task-oriented, another one is about chit-chat. And the reason why we need to separate it in the research development, because the objective function for these 2 types of systems are totally different. The goal-oriented one, we want to make the conversation as shorter as possible so that we can have very efficient interaction to finish the task. Like in the Java situation, we don't want we waste a lot of time to do the conversation. We want it can be as shorter as possible. However, for the social chit-chat, the objective function is totally in another side. We want the conversation can be as longer as possible, because we want to engage the user. We want the user can start a new topic and discuss with our agent. Then we can have much longer and engaging behavior. So for the machine, it's very difficult if we combine these 2 behavior, because we can only offer them one objective function. But as a human can easily switch between these 2 different modes. For example, when you are working, you jump into the task-oriented mode. Then you will do a lot of things more efficiently. And sometimes you can directly switch to the chatting mode and try to get more engagement interaction. So for the human can easily do that, but as a machine, it's very difficult to allow them optimize one direction instead of 2. But in the ultimate goal, we want our agent can automatically switch between these 2 different types and just behave like a human. Based on yesterday's lecture, we already know we can use the reinforcement learning to learn dialogue. So this is the basic goal-oriented setting. We have several components, and we can optimize each component individually and try to get the better system response. So we have the task completion, which we want to finish some tasks like purchase a ticket. And another one is the information consumption. We just want to provide the information to the user. So these 2 are goal-oriented ones. And today we will focus on the social chatbot. The difference between social one and these 2 are the state and the reward is different. We have very similar states like our history, conversation history, and we want to design a response as an action. But the reward is different. The reward for the task-oriented one, we can measure the task success rate, or we want to minimize number of turns. For the info part, we want to measure whether our answer is relevant to the question or not. And we also want to minimize number of turns. However, for the social part, the reward comes from engagement, whether this user shows interest and also engage in this conversation, but it's very difficult to acquire. We compare these two different types of systems. We call it intrinsically or extrinsically motivated reinforcement learning. Like this is the task completion part. Like we have an agent and we can have the reward explicitly, like whether this task is successful or not, whether we purchase the correct ticket or not. Then we can use reinforcement learning to maximize the reward. So we call this type of reinforcement learning in extrinsically motivation because we can define a specific reward for this scenario. So we can learn the RL by task-specific reward we define. However, it's good for the task-specific skill, but it's very difficult to flexibly deal with a new problem. Like if you focus on a certain domain, then you can only optimize for this domain. If you want to change to another domain, you need to redefine a reward for another domain. So it's a little bit difficult to flexibly change to another problem. Compare with the task completion part, social part setting is like here. It's a little bit different. We also have a reinforcement learning agent, but we do not have the explicit or external reward. The reward comes from the internal environment, which means whether we think the user is enjoyable or is engaging or showing the interest for this conversation. So this reward is not explicitly. So usually we enable the reinforcement learning by curiosity without the explicit reward we define. So it can be developed very broad. So compare with the task completion, it's a little bit flexible because it's pretty general, can deal with different type of situation. For the info part is a little bit around between these two different types because we may have more explicit reward, like whether this answer is relevant to the question. However, we cannot objectively get this reward. We still need to measure by the internal environment, just like enjoyable or the engagement level. So let's compare the supervised learning and reinforcement learning again. For the supervised learning, we need to collect a corpus and also the label, and we define objective function, then train our model. So we can deploy our model so that we can still improve our result if we get more and more label and training data. For the reinforcement learning, we do not collect the corpus with labels. We have an environment. The environment provides us the interactive conversation, so we can define a reward based on this environment. For example, whether we purchase the correct ticket or not. Then we optimize the policy by interacting with this target environment. So the target environment in dialogue system is the user. However, we do not have a lot of real users as a target environment so that we can access them to collect this behavior. So we need to create a simulation of this environment. So we call it like simulated user. We also define the reward, and we treat the simulated environment as the target environment, and we hope the simulated environment can behave very similar to the target environment. Then we can optimize based on this environment. But another way to get the simulated environment is try to collect a lot of conversation, like this interaction. So we can build the simulated environment based on this. And also the initial policy can also be used based on the policy trained from the corpus, which means we use the supervised learning as the initial policy, then we can improve using reinforcement learning. And this simulated environment can also be benefit from the collected corpus. So this is what we are doing usually in the practical way. We collect a lot of conversation, and based on this conversation, we can train or write the simulated user, and also train the original policy in a supervised way here, and then we apply the reinforcement learning to allow the environment and our system to do interaction and then get improvement. So this is the task-oriented dialogue system framework we mentioned yesterday. We have the database in the externally so that we can have the search query and to do interaction with this database. That's why we call it task-oriented, because we need to search the knowledge from the outside. If you want to do it fully in a fully data-driven way, then we assume we have a very big statistical model, like a neural model, which can handle the all information here. But if we do it in this way, then we cannot connect to the database, because if we need to connect to the database, we definitely need to have some information here, symbolic information here. Then we cannot do the optimization using backpropagation for the whole component. Okay, so why we think task-oriented dialogue should include the component-wise framework? Because they need to connect to the database. So yesterday we have a question about whether task-oriented dialogue system always have the database. Yes, because it focuses on a certain task. So the certain task also correspond to get the information from outside. So if we consider to learn the neural model without the database, then we move to the Chit-Chat setting. Like we do not need to access the outside external information, just directly generate the response. So that's how we do that. So we call it social chatbot. Let's see a very good example. It's called Xiao Eyes, which is a Chinese version of chatbot developed by Microsoft Research Asia. So in this product, the Xiao Eyes want to maximize the user engagement just by automatically generate enjoyable and useful conversation. Okay, so they call the Xiao Eyes is the neural conversation engine in Microsoft Research. So usually it's a fully data-driven engine. They will train on a very large social chatbot. And then they gradually include the persona model into this agent. Then furthermore, they want to have some image-grounded and knowledge-grounded knowledge, like behavior. Then we will detail all of them in the following lectures. Let's see then example of the interaction, how the people think Xiao Ai. In this user said, "Oh, no one compares. You are a good friend, Xiao Ai. I'll never leave you," because they really think they love to chat with Xiao Ai. And also, Xiao Ai is also emotional. They can provide the emotion like conversation and also have some feature as an image to reply the user. And we translate the Chinese into English. Probably you can briefly understand the meaning of the conversation. And why we think it's important, because if you see this is the usage frequency for this product. After they announce this product, more and more users use this product and also use longer and longer during the day. I think for me, I don't think it's reasonable, because originally I think why you want to chat with a robot, but I think a lot of people are boring, so they want to have some friends, or sometimes they have something, but they don't want to talk to a real person, so they just talk to the machine. So in this conversation engine, let's see then example. The neural model can learn a good shape of the conversation and try to provide us appropriate and coherent conversation. Like humans say, hi, how are you? Not bad, and what's wrong, and blah, 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 blah. So you can see the conversation is pretty general, and also the response is appropriate and coherent. However, if you want to have a slightly task-oriented way, like the human said, Thursday afternoon work sometime? Oh, sure, let me check when you are free. Then they think, oh, works for me. Then the human want to meet with this agent. They say, we can schedule a meeting 2 p.m. I'll see you there. Sounds good. Although the shape of conversation seems pretty good, however, this dialogue agent never schedule a meeting with this human. So if you appear there and you may not meet anyone because it's just a chatbot, although the conversation seems good, but they do not initiate a API call or some database in order to create a calendar entry in the database and in your calendar. Then you may not have the actual task completion in this conversation, although they can provide very good interaction. So we want to have the good shape about chatting, but for the task-oriented, we still need to have a component-wise system to handle this situation. So we can understand what kind of scenario we need to use for chatting, and then another for task-oriented. So for this example, we can have some solution. Like currently we generate the response, but sometimes we can retrieve the response based on some information we stored in our database or in our previous history. So, and we also need to incorporate the contextual information based on the embedding so that we can still train the end-to-end model, but the contextual information can be a vector that we can access to. So the user profile or knowledge base can be also there, then we can access this information and respond to the user. Because we want it end-to-end in the end-to-end version, so how can we use some goal-oriented information in this type of system? Let's review some neural net basics. I think everyone already familiar with it, so I just quickly summarize it. Machine learning can be formulated as a function-looking behavior, like speech recognition. Based on the function input is a speech signal, we can output the text. Image recognition, input is an image, and we want to output the category. Goal planning, input is the goal board, and we want to predict which is the best move for the next turn. For the chatbot, we can ask the question, and we want the output can be the answer of this input. So we use a lot of neural network. They contain a lot of neurons. A single neuron behavior is they do the weighted sum for the input vector and then put into the sigmoid function. So in this function, in this neuron, a single neuron, they can do weighted sum and allow the output value between 0 and 1. So for a single neuron, we can adjust the W and B so that we have different Y. So how to train a model? For example, the input is this image. We can formulate this image into a vector and as an input into this neuron. We can adjust W and B so that if Y is larger than 0.5, then this figure belongs to digit 2. Otherwise, this figure does not belong to digit 2. Then we can, if we have a lot of pair of the input and output, then we can have the good weight for W and B. However, a single neuron can only handle binary decision. That's why we need the layer of neurons. So each neuron focuses on the digit. Then we compare which is the best, the maximized one. Then we decide what is the final digit this figure belongs to. Then we can also connect a lot of layers of neurons so that we build a deep neural net. So which means we have multiple hidden layers. Or if we only have 2 hidden layers, then it also means deep neural net. For the natural language, we usually use recurrent neural net because we consider the temporal information in the natural language, because I love you is different from you love me. So if we directly put into the deep neural net, then the order information is not considered in the model. So usually we need to model the temporal information so that we can differentiate the I love you and you love me. So the reinforcement and the RNN can be used in this way. So in the social chatbot, how can we use the RNN to generate the response? This is the input. We call this source. We can treat it as a conversation history. Then we use RNN to encode all information from our source. So each word can be featured for each type step, and we encode the whole sentence information, then decode the target response. So this is the big RNN containing an encoder and a decoder. In the decoder side, for the end of sentence of the source one, then they need to generate the first word of the target response, then one by one. So the whole model can be trained in end-to-end manner. We just need to collect a lot of pair of input and output. So this is the maximum likelihood formulation. We want to learn what is the best target response, which can maximize the probability given this source sentence. In this situation, we allow the model to learn how to generate the dialogue from the offline data. So in this situation, we do not have the state. We do not have the action. We do not have the intent and the slot. We directly put a lot of sentence and sentence pair. Then we call this as a sequence-to-sequence model. So the input is sequence and output is also a sequence. We just need one RNN, including encoder and decoder, to train the pair of the data. So you can consider as a dialogue. We do not only have the sentence, target sentence and the source sentence and the target sentence. We have a lot of pair of the source and target. So we can use the hierarchical version of the sequence-to-sequence model. In this model, this one is the RNN to encode the sentence information into a sentence embedding. It's called the utterance representation. And they additionally use a dialogue level RNN here. So this RNN, for each type step, the input is an utterance representation, and they encode the dialogue history and try to decode the dialogue response using another decoder here. So you can imagine that there are two different sequence-to-sequence models. One is based on the sentence level, one is in the dialogue level. This also additionally incorporate the Gaussian latent variable within the dialogue level RNN. So the idea is we want this latent variable can learn some abstract information, for example, the topic or like the sentiment. Because within a dialogue, probably the topic may not change a lot. So if we have this latent information, probably they can learn the better topic transition and then generate the better response. Otherwise, we may jump another topic by only single turn. It's not very reasonable. So adding this latent variable, they try to learn some latent information and get a better result. But the whole architecture is the same as the previous one. These two are from the same research group. However, the current neural response generation, and we call the Chit-Chat setting as the neural response generation because they usually directly generate the response, suffer from an issue, which is the Blandness problem. For example, the user said, how was your weekend? And the agent responds, I don't know. And what did you do? I don't understand what you are talking about. And it's getting boring. Yes, it's what I'm saying. So this type of response, because they just select the best target sentence which can maximize the probability based on this source. So the agent is very smart. It already learned just using this general sentence, then they can answer any type of question. Like we can always have this answer, then you think this pair of the conversation also reasonable. It just do not include any meaningful information. So usually they learn how to generate this type of general, like meaningless sentence in order to respond to the user. So this is a common issue for the neural response generation. So how to deal with this issue? First solution is try to generate a diverse response. So a work they provide, they revise the objective function into a mutual information setting. So they revise the objective function into this one. This is a mutual information. So they want to get the target sentence which can maximize this score. Okay. So we can rewrite this equation into this way using Bayes' rule. And the first term, which is the standard likelihood based on the source, what's the target sentence probability, right? And the second one is the anti-language model, like the probability of this target sentence. So they add another parameter here to control the anti-language model effect. And another one is using the Bayes theory to rewrite the original equation into this way. So you can check the detail of how they rewrite it, but it's pretty intuitive. Like they just change the given source, we estimate the target probability into given target, we estimate the source probability. So this have two different settings. Then this one, a larger lambda indicate the output may be more likely to be ungrammatical. And this one is used in the rescoring. Okay, so let's compare if we use the mutual information instead of the original maximum likelihood, whether we can improve the performance or not. This we use the standard LSTM to train the sequence-to-sequence pair. The y-axis shows how many distinct tokens in the generated target. So originally, standard LSTM always generates very general sentence. So the number of distinct tokens is less than, it's only like 2%. If we add the mutual information using the anti-link model, that the second equation there, we can slightly improve the diversity of generated sentence. If we use the bidirectional one, then we can further increase the performance, which means when we generate a sentence, we need to consider this one is we can maximize the probability of this target sentence given the source, but in another way as well, like whether we can predict what's the source sentence when we only look at the target sentence. Then if you have very general response, then we cannot predict the source sentence, right? So the objective function score will be lower. So if you consider the two direction, then the performance will be higher. Like in this way, we want to select a target sentence. They can maximize this term, and also we can, based on this target sentence, and we can predict what the source sentence is. Then we can avoid the Blandness issue. So let's see the sample output. Originally, using maximum likelihood, this is the generated sentence. Of course, I don't know. I'm not sure. I'll let you know. Although it seems reasonable, but it do not contain any meaningful information, right? So there's 32% of the response are very general, like, I don't know what you are talking about, oh my God, like this kind of response. But if we add the mutual information, you can see that, can I have one? Of course you can. It will be better than only reply, of course, because based on this response, you can imagine the source sentence may ask the question like, can I something? And also, what next? I think it's better sign, and how many depends on, and also makes your mouth water. They're delicious, so they have the connection between the source and the target compared to the original sequence-to-sequence architecture. So you can see that they automatically learn some common sense, like brew and drinking, they have some connection so that they can automatically generate this word just by the source sentence, just by slightly change the objective function. However, we still have another issue. The issue is about inconsistency. In the real-world conversation, in our setting, we collect a lot of conversation from different people and different location and different type of multimodality, and put it together and learn our model, a single, very large model. But if we want to provide a personalized engine, probably we need to consider different type of information, like the person's profile, or what they are seeing, or what's the emotion currently. So in order to get better conversation, we need to include a lot of multimodality. So previously, our neural conversation model suffered from persona inconsistent issue because we put a lot of sentences together and learn a huge model, right? So it will generate very weird response, like, where do you live now? I live in Los Angeles. And if you change the question but ask the same information, in which city do you live in? They generate another location. It's common, right? Because they just maximize the output sentence based on the source. They do not consider what's the semantic information behind this sentence. So they do not know you just ask the same semantics. They just generate a response. So you can see a lot of inconsistency, and you think this agent is a little bit weird. It's not a human, it's a machine, because they suffer from this issue. So how to deal with this problem? We want to enable a personalized model, like in adding some persona into our agent. If we want to learn where do you live, we want to generate the response which includes some personal information here, like this person lives in England. So how can we do that? We have the word embedding, right? Word embedding will tell us some information about the England is near like London. It's just London is the city in England, right? And we want to learn the personalized embedding. We call it speaker embedding. For example, we collect a lot of data from different speakers, and we train the speaker embedding based on each person. So we have the speaker embedding. So this maybe some speakers are similar to each other. They live to very close place, and using the speaker embedding in the decoder side, we fit this speaker embedding for each type step when we decode the sentence. Then this model will try to generate the embedding which is related to the person's data. So that's what we are doing. When we learn our model, we need to include the speaker embedding. Then they can learn the correlation between this speaker and also the speaker's response in their personalized conversation. So for different person, they can have a different location and also have very consistent response. So this is the inconsistency when we do not include the speaker embedding. But if you add this, the conversation becomes better. Where is your hometown? I'm from England. Where are you? They change the question type. Like they can still get the same answer. And which city I live in London is also consistency. So compare with the original one, if you have the same question, they will change the specific information as in the response. But if you include the speaker embedding, they will know this person major in business. So if you ask what did you study in college, they still have the same answer compared to the original one. Then previously we want to collect the data for different speakers, but it's a little bit difficult to collect conversation data for each speaker, right? Because if you release a product and a lot of new users, they do not provide their own conversation data. So how can you personalize for them? Another way is try to use other data instead of conversation data. So that speaker may write a lot of passage on the web. So you can utilize that information using this architecture. So it's like multitasking. This is the original speaker-independent conversation model. Here, if you use the written text from the new user, they do not provide the conversation data, but they have a lot of passage they write. So you can use this and try to allow the decoder share the parameters. Then you can learn the speaker role in your conversational model. So let's see then example. So here, the speaker role is a support person. The domain is we want to have some technical support. So if we want to learn how the support person will say, we can use that architecture to simulate the support person saying. So this is a scenario. The user wants to get I'm getting a look back to login page. So the compared baseline, if we do not train the model using the written text, then the baseline will say, oh, okay, thanks for the info. But if you add the speaker style information, they will have more polite interaction. I'm sorry to hear that. Have you tried changing blah, 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 blah. So if you include the information from a certain person, then the conversation behavior will be more similar to that person. So different person may have different speaking style. Then you can automatically enable this different style into your conversation generation. After that, reinforcement learning again. We want to apply reinforcement learning. But why? Because usually if we have a supervised learning agent, they just try to answer this question and then finish the conversation. But it's not a conversation, it's just like a single turn. If we consider a reinforcement learning signal, they will try to have a better conversation. Then we can define what a better conversation means. Like if we want to engage the people, probably we can have the length of a conversation as a reward, or whether this user smiles or think happy. Then we use the signal as a reward to slightly revise our response generation. It's a dialogue policy. So they will generate more interactive response. So in this situation, like the agent do not directly answer this sentence. They also provide another question. They want to get the longer conversation. If you only say, I'm sitting, then the dialogue just finished. So if you can answer, I'm sitting, while you are asking, then the user may provide further information and the conversation can be longer and may be more engaging. But the next step is how can we explore the intrinsic reward, which is like whether this person think happy or think enjoyable, which is the information we cannot automatically acquire. So sometimes we need to collect the user rating from the user side, but sometimes we cannot have that rating like very directly, and a lot of people do not willing to provide this information. So another way is use the third person to monitor the conversation and provide a rating for the conversation, and we can treat it as a intrinsic reward as well, and to enable reinforcement learning. And furthermore, how can we combine a task-oriented type of system together with the social chit-chat? This is the social chit-chat. Usually we do not ground into the knowledge ontology. we want to interact like a human. For task-oriented one, we just want to ground it to the knowledge base and try to support the user's decision. So if we do the chit-chat, the weather is blah, 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 any recommendation, we want to recommend some information which is directly related to the user, what the user asking. If we do not ground it into some knowledge, then we cannot provide a good suggestion, right? It just directly provides some natural response, but they may not actually related to the information this user asking about. So how can we ground information in the chit-chat setting? So a lot of research are trying to dig into this field. Like this is one to ground into the image. Here, in this neural model, they provide a tweet data and also some photo together with the sentence. And then they ask some question. The neural conversation model will have a little bit better response related to this image. Then we can treat this conversation ground into this image. Like some of the damage done is that at your house. If we do not understand this image, we cannot have this response, right? So in order to directly generate a sentence, we still need to consider this information. This is a very simple idea because we just use like a CNN to extract the feature as an embedding and fit this embedding into our sequence-to-sequence model. Then we can generate this response. It's very easy. So we can generate response and try to ground into any type of multimodality signal. Like the database or geolocation, you can use the similar architecture to adding the additional information and allow the sentence can be grounded into this signal. Another one is try to use the knowledge ontology. This conversation history want to go to the restaurant tonight. But if we directly use the sequence-to-sequence architecture, we cannot provide very useful information about this restaurant because we do not extract this is the restaurant slot, right? So the good response may be try these things, this is the dish provided by this restaurant. But if we do not have the knowledge base, how can we generate the suitable response? We just generate another dish's name, probably it is not provided by this restaurant, then it's also a good conversation, but not useful, and the user may not like it. So how can we do this? The idea is we want to use a memory to store a contextual relevant fact. Like we have a lot of fact as a memory, and we can encode this fact into a lot of vector. And this encoder will try to access the vector here and then decode the information directly. So knowledge can be stored in this part. But how to collect this knowledge? You can acquire some knowledge ontology and store all knowledge into a vector and then put here. So this is the static information. Then the encoder can automatically consider this information and then decode the sentence. Let's see an example. We want to have we want to recommend the dishes for the Japanese restaurant. Then we can collect the conversation to provide the word which is not related to the content word here. This is the conversation data. We want to have the form, like the shape of the conversation. But for the information here, which can be acquired from the memory, like we previously stored. For example, we can acquire this information from the restaurant review. Like in this restaurant, a lot of people will comment something, and we can use this sentence and try to encode it into a vector and put in our memory. Then we can automatically know, oh, we can recommend these dishes because we already accessed a memory from this sentence. Like we automatically put a lot of comment into our memory. But in this way, this comment is stored in a static way, so it's not changed dynamically. For example, you cannot allow the system to automatically generate the movie you will see tomorrow, because the movie theater may have the dynamically changed database every day. So if you encode all information into the database, into the memory, then you cannot generate a reasonable response. But for this recommendation, it's okay to do it in this way because it's not dynamically changing. So let's see the response. Like the person talking about some airport, so the response said, oh, nice airport terminal. If we do not have the comment, probably it's a bad airport terminal. So we can have like a suitable response. Probably this is what the user really want to see. And also for the restaurant, you can try different dishes provided actually from that restaurant, as well as this example. So in this work, they use 33 million conversation, and they just allow the user to rate the conversation whether it's good or not. And the human user said they think this kind of response is more useful, and they want the agent to provide like meaningful suggestion instead of a good like natural response. So how can we evaluate our system? Like I think the best way is try to get a real user evaluation, but sometimes it's very difficult. So for the dialogue system, in the task-oriented one, we can have the objective evaluation, and we can use user simulator, or we can have the crowdsourcing to allow the real user to rate our system, or we can directly measure whether the generated response overlap well with the original human written response. So for the crowdsourcing for system evaluation, usually we will ask the user, you need to focus on the coherent and also whether the information is useful or not, and what do you think the confidence, and what's your expectation, and also do you think it's useful or not, it's a good system or not, and whether they accomplish your task. So for the task completion, you can use this type of question to ask for the feedback. But for the social bot, it's a little bit different because we cannot ask whether you think the task is complete or not. It's not like a good answer in the social scenario. So how can we evaluate like the engagement level, or whether they have a personalized or the speaker role, or whether the content is useful or not? This paper provides a very interesting idea to do the dialogue evaluation. They call it ADEM. What they are doing is they collect a lot of conversation, and they think usually you do the objective evaluation is we have the model response, and we have a human written reference response, and we just compare these two using some red or blue score. But it's a little bit weird because it's possible you provide a good response, but there's no overlap between your response and the reference response. Then you get a very low result. So using this automatic evaluation is usually biased and also correlate poorly with the human judgment. So they want to tackle this issue. They provide a solution. They just collect a lot of human score for the conversation. For example, you collect a lot of conversation and you ask the human to provide a score for the conversation, focus on the certain perspective. For example, whether it is coherent or not, and you have a 1 to 5 score for the coherence, and for the naturalness, you also provide a score. And they collect a lot of conversation along with the human score. And then they train a model to predict the human score. Then they call it ADEM, just Automatical Dialogue Evaluation Model. This model, given the conversation, they will predict a user score. And then they show this model prediction correlate better with the human judgment compared to the original automatic evaluation. So they think they can generalize to some unseen dialogue, because sometimes if you use the automatic evaluation, the unseen dialogue may not have the good judgment, but this model can generalize better compared to the automatic one. Okay, so let's move to the last part, the recent trend and the challenge. Recently, there are a lot of interesting tasks. For example, this is a video highlight prediction. They have a video about 2 players playing video games. And a lot of people are chatting, discussing about this game. And then they try to capture when is the highlight of this video game. So the model they use is pretty simple. They just use the video information and the chatting information and use MLP and do the prediction. But you can use a different way. But the task is interesting. You can have the conversation and also the video information. Another one is also include the visual. It's called Guess What game. In this game, there are 2 players. One player want to guess what object is selected, and they cannot see the selected object. They only see the whole image. And another person, they know which object is selected. So the questioner need to provide a lot of question, and then after the question answering, they just guess which object is selected. And another response agent just generate yes or no response based on the questioner's question. So for example, the selected object is this. So is this a person? No, blah, 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 blah. And then the agent need to efficiently guess which object is selected. So this based on the dialogue information and also the visual. You need to ground it into this image. And another interesting one is try to use natural language and then generate the image. Like I think it's a good scenario for like the Photoshop. A living room, they directly generate a living room for you. And you can edit the living room, like a white sofa by the green wall, and they just add it, and they will automatically generate based on your conversation. Let's see another similar task. This task is try to use the task to guide the image colorizing. Like this is the original image, and you can use the natural language to have different color of this image. Then you need to generate this image based on this original image and also your description. Another task is also task guided, but it's about image segmentation. For the input image, we need to know at the middle of the kitchen lies a blue chair, so they will have the image segmentation correctly or better. So you can think we can use a lot of natural language technology to help the original image processing task. So in this task, this is from Microsoft, I think. They provide a multi-model reason net. They want to learn the the semantic here and try to get a better image, correlate better with this description. Okay. Finally, we summarize the challenge. First, the human-machine interface is a very hard topic, but it's very challenging to build a good one. And it's the same as yesterday. We have a lot of DNA. We need to collect data with label. And another issue we need to focus on is how can we integrate the knowledge into the Chit-Chat setting. Also, we need to balance between the efficiency and engagement, because sometimes we only focus on the efficiency and ignore the engagement. And sometimes we just want to engage the people, but the user do not interested in your conversation. So how can we balance between these two? Also, personalized specifically for Chit-Chat is very important, because we want to chat with the machine and we want to chat the person who knows me more and can provide me more personalized behavior, the conversation. So if we want to provide a good chatbot, probably we have to deal with the personalization. The last one is how can we integrate the task-oriented and Chit-Chat dialogue into the whole architecture. Then we can have the knowledge-grounded Chit-Chat, or we can have the Chit-Chat type of interaction in the task-oriented setting. How can we integrate these two? It's still open discussion. Okay, thank you.
We have some time for questions.
My question is about traits and temper of chatbot. Our purpose is to simulate a human, so human have some traits. So how to create some traits to chatbot, like what movies and books it likes and so on, and how use it in creation of the conversation.
You mean for the dialogue bot, you want them to have some persona, right? Yeah. It's I think a lot of product just directly set the personalized profile for the bot. For example, for the shell eyes, they just formulate it as like the 20 years old girl or something. Then have some major and some interest or some hobby. Then they directly formulate this into before they deploy this bot. Then after that, if the user asks about anything related to this profile, and they will automatically output this information in the designed profile. That's what the current product is doing. But I think it's also interesting to learn the profile by interaction. For example, when you build a bot, you can allow the user to formulate what they want this bot look like. For example, you want your bot is a child or your boyfriend or your girlfriend, and in the beginning of the bot, they will ask, oh, what do you want for this bot? Then they just based on the interaction to learn the knowledge, like the profile for this bot. So for different person, the bot will behave different because the bot profile is designed by the user. This is another way.
Yeah, but can we just declare some profile for chatbot and use it in conversation, and maybe then we can replace some information in this profile, and it will be automatically replacing in conversations. It will be used there.
I think yes, we can probably do that. And I think I remember some bots, they use some like the conversation history for the conversation between the bot developer and his dad, because his dad already passed away. So they want the bot which behaves just similar to his dad. So they use the conversation previously and to train this bot. And then probably the bot can have the conversation very similar to the his dad is saying, and probably some knowledge is from the history or some information is from the history. So it's just like the conversation between the developer and the bot they want.
Yeah, and what techniques can be applied here? It will be like just pattern. It will be patterns in places, and information from profile will be placed on the particular place in the sentence, and then this reply will be shown to the user. Or we can have some more predicamental techniques.
I think there are two different ways. One is just, and you have a lot of conversation. Like you just want this bot can learn automatically from this conversation and as their behavior, like their persona. And another way is you do not have this data and you just want to define some rule in their profile. In this way, for example, if you define like the location or like the hobby they like, then probably you need to slightly extract the semantic slot from the conversation. Then each time you see the semantic dimension which is related to what you are defining, so you can automatically generate this response to the user. Then your bot will behave like what you are designing.
Actually, I have a couple of questions. First one is about social chatbot. What if we don't sort of pretend and try to project the persona into the chatbot, and we just make it explicit that chatbot does not have any origin, it does not have any biography, name or something, and if we make it more sort of active towards user, so it would be not a user trying to figure out something about the bot, but bot trying to figure out something about the user, and maybe if usually people like talking about themselves. How would that work? What do you think? And maybe you know some precedents about that.
Oh, I think it's a different perspective. Like, because users have their own profile, and bot have their own, and it could be possible the bot profile is similar to the user one, or they have the total different one. But I think it depends on user preference. If the user prefer to interact with the similar person, then we can acquire the persona from the user side, then embed into the bot profile. But I am not sure whether the user like this in this way. So in another way, probably they want another type of person. So we can acquire the interaction from another person they want the bot to look like too. So this is another way. Probably you can fit the conversation just like the conversation you between you and the developer and his dad. So they can try to allow the bot to acquire the information from his dad and have the profile for his dad.
I guess my question is not to like how we make a chatbot similar to user, but can we make interesting chatbot with no persona and no history, personal history, but just acknowledging that I'm a bot, I live in a machine, I know nothing about the world, like teach me, what's your life like, and etc.
Okay, it's, I think the situation we met is the user always like to ask the bot the profile, like what do you like or what's your name? If we do not have include the persona in the bot, probably if you ask what's your name and what others call you, and they will respond differently, then it's a little bit weird, right? Because during the Turing test, we need to allow the bot just behave like a human. So if they say something inconsistently, probably we think it's not a very natural conversation. So I think the issue is from here. So I'm not sure whether we can have like a bot which do not have any persona. Then you may have some inconsistent result, but it's also natural response. So I think it depends on what the user wants to ask, because the user always will ask a lot of knowledge related or like profile related information.
Okay, thank you. And the second question is about goal-oriented chatbot. I was wondering, because in the given examples, and as you said, we try to make a conversation as short as possible. And when the bot provides some option for some restaurant, the user says, well, yeah, great, thank you, can we make booking, a reservation, and that's it. And I'm just thinking how I usually choose a restaurant. Like I spend half an hour trying to figure out all different options and try to make some choice. So from your experience, maybe, do users get satisfied with just one response, or they try to get some more information and they have some more complicated paths, decision paths?
Oh, I think it's more complicated. I think they, because they can continue the conversation and ask different type of information or other restaurant, but in the neural model, they can still generate a response based on the history, right? So if your question contains a certain restaurant, then they will answer this restaurant related information and try to recommend to this user. And if they acquire different type of different comments for different restaurants, then they finally decided, I think there's another way. I think a lot of like the company want to integrate this Chit-Chat with the task-oriented bot. The way they are doing is, after they think they have the suggestion, right? And after they think the user want to book the table, then they switch to the task completion bot. Then, oh, you want to book the table for this restaurant? Okay, I can help you. Then the task-oriented bot appear. Then they can do the interaction based on how many people and what's the location and what time. Then they switch to that one. So I guess a lot of companies want to get more transaction like the task completion. So they will always recommend different type of like movie or different type of restaurant. If you have a little bit intention to see a movie, then it will just suggest you. So this is one, I think the direction what the leading company is doing right now.
Okay, thank you. I have two questions. The first one is about how many actually agents can interact in the conversation. Or give an example was one-to-one conversation where is one human and one agent. Is there any experiments where, for example, is like several humans and one agent or something like that?
Oh.
Like a more realistic situation when you're not one-to-one, but
Yes,
group of people.
I remember there's some research work, and which is trying to tackle this problem, but it's definitely more challenging because they need to understand this different person, and different person may have different interests, or engagement level, and then they will try to jump into the discussion in a right timing, and also may have a good, they would need to choose which person we need to respond to, and switch to different person or just like a human. So this more difficult scenario, but it's possible.
Yeah, it's like additional level to our architecture where our bot is deciding when to reply or not.
Right. They need to decide which is a good timing to reply, and also who is the person we need to reply to, or we need to reply all, or who is asking the question to me.
Yeah. Okay.
Yeah.
And another one question: can you please explain more detailed, with more details about how user simulator works, like how to build it or where to read about it?
Oh, for the Chit-Chat, if you want to use the simulated user to do interaction, it's more, I think it's much easier because you can directly use your bot to talk to your bot. Okay. Because they are all trying to chatting, right? But there's another situation you may met. If you directly allow them to optimize anything, and they will try to use in very efficient way, like to use some code to do interaction. So you also still need to make sure the output is a natural language and also the understandable.
I know that was, I don't remember, about 2 years ago, some experiment where two bots developed their own language or something like that.
Yes, because if you optimize in the two sides, then they will automatically learn, oh, this is a more efficient way to interact with another machine. So usually you need to have the bot, which is the simulated one, to fix it. And then you train your bot here. Then you can have the reinforcement learning signal based on the conversation you collect. Then you train this bot, and you fix this part and train this one.
And what about task-oriented chatbots with simulated environment? Is it possible?
Yes, for the simulated user in task-oriented setting, then you need to build another system, because in the task-oriented setting, the purpose of two parts is different. One is want to accomplish some goal in their mind, and the agent is trying to help the user to accomplish the user's goal. So the agent do not know the user's goal, but the user knows their goal. So in the user simulation in a task-oriented setting, in the beginning you need to sample a goal, and the user will follow the question which is related to their goal and to answer to the user, to the agent. So you can train the agent side.
Okay, thank you.
We have time for one last question. Okay, so if you've run out of questions, then let's thank our speaker.
Thank you.
You can now.
Maybe we can take a picture together with
Okay.
can you switch on the first slide? So we have a title.
It's too far away.